Still waiting for the slide. Beautiful. Hello. As Mike said, my name's Dave. I'm a machine learning chapter lead at Spotify and have glad to been part of the Mass TLC machine learning community for a good while now. How many of you have ever used Spotify? All right, great. Ooh, that warms my heart. Thank you. The reason I work there is that I believe music improves lives. And actually, for this talk on managing your machine learning portfolio, we're going to talk about an example or an analog from a music experience use case. So we're going to take this guy here. His name is Rob. And for our purposes, he's going to be your customer. So you're in the business, for the purpose of this talk, of providing some sort of music experience. And Rob is looking pretty frustrated there. The reason he is he's surrounded by all these things that seem to be able to provide some music experience to him, but he's not able to do that. And there's a lot of reasons that might be the case, but I want to focus in on ones related to machine learning and the set of machine learning activity at your organization or your machine learning portfolio. So let me ask a question. If you think for a moment about how many machine learning models are important in your organization. So let me ask you to raise your hands if it's at least one. At least one model is important to your organization. Okay, you can get them up, be brave, it's cool. We're gonna keep them up. I'm gonna do the count thing and then you're gonna drop your hands. How about if it's more than one? Keep your hands up. All right, still more than one. You got the number in your head. How about like close to, right, above 10, let's say. Anybody above 10? All right, so we got still a number. How about above 100? All right, still some hands up. Good, good. So anybody above 1,000? All right, maybe. So my point is, it's not the case that we all have just one model, despite the fact that a lot of academic papers are written about optimizing a particular model. That's usually not the case. There's usually a lot of moving parts. So I want to have you think about all these vinyl records that are surrounding our buddy Rob there as your machine learning portfolio. There are lots of models, there are lots of tools, there are lots of other things. And that can lead to a challenge because Rob's not experiencing music. Your customer is not having as good an experience as they could, maybe in part because your machine learning portfolio isn't being managed or groomed or cared for in the way that it could be. So this is what Rob wants to have happen. He wants to have this full music experience where everything fits in his life in the way he wants, and he gets to stare off into space and think about good breakup songs. But he's not having that experience right now. So you might say, well, why don't we just build that thing? We got a picture of it, let's build that. But the challenge is, Rob is not your only kind of customer. There might be somebody like this, who's not listening on headphones or has a record player that's in a different shape or for a different place. Or this, maybe it's a group listening experience where people are talking about music together. Or maybe it's this, some super hi-fi loving, like, wants the perfect record. Or maybe it's even this, a DJ who's actually using your thing to produce an experience for people like this oddly familiar looking person who might be dancing to that. So that's a challenge. You have this challenge that you have a lot of different customers who might have different shape use cases, and you've got all this energy, you've got these ways of approaching ML, these different models, but they're not necessarily really aligned in the way that would be optimal. So I feel like all machine learning software products, maybe even all software products, are at the bottom line in the business of connecting your customers to your domain. So in the case of this offering that we've been talking about, it's about connecting people with music. And you can imagine different pieces of that experience. There's the thing that's directly interacting with the customer. There are tools or means of delivery of that thing, and there may be bits of content or domain representation. So in that particular picture, Rob was listening to the Talking Book album by Stevie Wonder. But unfortunately, sometimes we end up building experiences that are a little bit different. So Rob has these over-ear headphones, but maybe the thing that we can provide, because we're not as aligned as we would like to be, is just the headphones that sit on top of the ear, which is fine, but they're not exactly what Rob wants. Or maybe in terms of a delivery system or record player, we have something that works, but it doesn't quite fit in Rob's like cabinet, and we had to like bubblegum and baling wire it together in the garage. And maybe even worse, we don't have talking book in our model of our domain. I mean, we got Cool in the Gang. That's cool. Spirit of the Boogie. That's, they're kind of similar. They both got some funk in there, but there's also some stuff in Stevie Wonder that was more tugging at your heartstrings. So what we want to give is the experience on the left. And what often, when our ML portfolio isn't well managed, we end up with something closer to the experience on the right. So I want to talk more specifically about 3 kinds of challenges for machine learning portfolios. One is modeling that's out of place, where you're investing in a place for modeling that isn't really optimal. Another is crude tools, where tools aren't the shape that you need them to be. And third, and perhaps most important, is under-supported people, where the people who are doing the work don't have the support they need. Now, to do the addressing of those challenges I just mentioned, I need to first build a framework in your head for the machine learning product lifecycle. So hold with me here. We're going to build this framework, then we're going to apply it to each of these challenges. Actually, even before that, I need to build a framework in your head about kinds of research and development work. So I think that the work of any of us in this room who would consider us doing research and development is somewhere in this space. And maybe it's all of this space, maybe it's a very focused part of this space. Let me explain this space to you. So there are 2 dimensions. The horizontal dimension, the horizontal axis, is about how sure are you that the thing you need to do is possible. Let me flesh out that axis for you. So starting at the left, it may be that there's knowledge already within your organization that this is possible. So maybe it's some sort of straightforward engineering task. You don't know exactly how long it's going to take. We all know that there are weird dependencies that come up. There are other things that come up. I'm not saying it's like, completely brain dead, but it is something that your organization knows how to do. Moving a little bit to the right, something that the world knows how to do. So maybe there are some published papers that aren't exactly in your domain, but they're close enough. Maybe there's knowledge at other companies that you've been able to glean in events like this one where you can do that. Then at the far right is unknown to the world. So this is a case where there's, say, a PhD student who's finishing her dissertation and has just discovered that there's a new way to do a thing. So that's the horizontal dimension. So if you like, it's the technology risk of the thing that you're doing. The vertical axis is about how sure you are that this thing is valuable. So if you like, that's the market risk of the work that you're doing. So let's start at the top. That's where you're not at all sure that this thing is valuable. You may just have some idea and you're like, hey, maybe this could help somebody, I don't know. Moving down a little, you've thought about it enough, maybe you've done some internal prototypes, and you think, I have this like set of reasoning that grounds a hypothesis as to why this could be valuable. Farther down, you've actually done some amount of experimentation on that hypothesis, and you've got some amount of evidence that your hypothesis about its value is true. And then finally, you know the value of the thing. So I want to give you some examples to help bring this space home. So at Spotify, we have a Hack Week every year. I'm wearing the t-shirt from the last one. Often work that happens in hacks is in that discovery quadrant of the R&D framework here. Not always, but often it's about, hey, I could really use this thing, or we talked about this, and wouldn't it be cool if we had this feature? Occasionally, it's somewhere else where you're going off in pursuit of some new approach that is going to show something's possible that no one ever showed before, but often hacks are up there. In contrast, we have a tech research department at Spotify who are not in the business of delivering product, but instead of delivering ideas and approaches and code that can help our product advance and move to that place of increased value. So they're often in pursuit of things that are unknown to the world, and they're publishing it and demonstrating that and participating in that academic context. Our teams, or we often call them squads, they are at different places at different times in these quadrants. So often you think of sort of traditional teamwork as being in that bottom left corner. So we know how valuable something is, we know how to do it, we got to do it, we got to deliver, we're going to deliver on this. Sometimes teams do things like design sprints. I'm not sure how many folks have done design sprints here, but this is often at a place where you have some beginning of a hypothesis of something that's valuable, and you work together to think about what thing could we imagine delivering. Let's give it some shape that might be able to capture this value. So design sprints often happen there. They're a little more sure of the value than just a hack. So teams sometimes are in that space where they're participating in design sprints. And notice in this case, the team is a little more to the right. So it still might be stuff that's mostly known to your organization, but you might be starting to pull in ideas that are more known to the world as you're pursuing some new product idea that has this design inside it. And then another place might be, we really know the value here and the team is going more and more into that space of outside the organization, known to the world. So I give you these to try and give you some intuition, some feel of this space, and perhaps you can think about where does your work fit in this space. Okay, now that I've built this space in your head, remember I'm going back to these 3 challenges of machine learning portfolio management. I want to talk about the life cycle of a machine learning product. So there are a few ways to do it, but the one that I would recommend is where you start actually from building no new machine learning. You start from a product idea, from a feature idea, from someone saying, you know, if we could do this thing, people's lives would be better. It might be a really incremental thing on top of an existing product. It might be something that's really new, that's like completely in a different space. But if you can attempt to build something that at least functions without having to do new ML work, then you can very quickly iterate and explore and think about the value. Then often, after you've built a bit of hypothesized value, you might say, okay, let's have a prototype ML product. Let's go a little bit outside of our organizational knowledge, or at least go to the edges of it, and think about what kinds of ML we know about that we could apply here. Further on might be a minimum viable ML product. So this is getting to the place now where you're experimenting with something, you're putting it in front of users or against the data that is most representative of users. And notice here there's an increasing shift to the right. So as the value is proven, the pursuit of new ideas is invested in more and more. Then you might have, say, a mature machine learning product. So now you're at the place where it's not just minimum viable, it's that you've really gone after the optimizations that are going to maximize the value, and you've pulled in ideas from outside of your organization. And then what might happen is you find out that there's some corner of your domain, some corner of your user base that, despite the fact that you've got this mature product, is still underserved, and you feel like there's potential there. So that's where you might go to a V2 and have a new implementation where you might need to go pull in some research that's unknown to the world now, or go even do that research on your own, but you have this very specific product idea in place so you can be constrained in that pursuit. So this is my preferred machine learning product lifecycle. I've seen it a number of times. There are variations on it, but often it has this shape. I want to talk about another one briefly, just to acknowledge that this is not the only way to build machine learning products. And that is more of a research or academic-driven ML product lifecycle. So this is often where you'll have someone in an academic context, and they will have something that's new in the universe. They have no idea if it's valuable to anybody, but it was just a cool thing to think about. So they wrote a paper about it, and maybe it makes its way down. Similarly, in an industrial lab, that might be a bit more focused on the value axis, pursuing things that have somewhat hypothesized value. And you'll notice here the progression here in contrast to the previous slide. The previous slide was from the upper left diagonal, or from the upper left corner to the lower right on that diagonal. This is going in the opposite direction. So whereas my preferred ML product lifecycle, you're not doing as much joint exploration of value and possibility. Here you're optimizing for both at the same time, which is a little more difficult. But if you have some really great academic thing, you might be able to value that as well. Okay, but we're going to focus about this version of it, from the upper left to the bottom right. So now you should have in your head the machine learning product lifecycle. We're going to use that thing to go back to these 3 challenges that I talked about for managing your machine learning portfolio. So one is where you have misplaced modeling. Let me give you some examples of that and our analogy back here with Rob. So we talked about these, the expression in the domain of, well, we don't have Stevie Wonder, all we have is Kool and the Gang. So sometimes what happens inside our organizations is you have some model, some entity representation, something in your domain. And what you say is, let's build something that's kind of like it, but a little bit different. So we had the vinyl version of Spirit of the Boogie. Now we've got the tape version of Spirit of the Boogie, which could be useful if what you're going after is people who still have cassette tape decks. I think there's probably more people with vinyl record players than tape decks, but it could be useful. But the challenge is, when you were building that, you could have been building the talking book, the Stevie Wonder, the domain representation that expanded your domain to include that as well. So that's one, in this analogy, that's one kind of bit of mismanagement where you're investing a lot at the domain level, doing things that are somewhat proximate to other things that you've done and not covering the space that your customers are interested in. Similarly, up here at the level of these generic black headphones, you might like to say, hey, what if we had the really over-ear ones that Rob's after? But instead, sometimes you just go crazy with like different flavors of the thing that you've already got, prematurely optimizing your user experience for things that you think might be good variations, but might not actually be what your users care about. And sometimes there are models at that level that are variations that aren't good investments, although there may be some customers who want like the neon yellow headphones. Finally, you might build an end-to-end model. So the analog here for an end-to-end model is a live concert. It's a single user experience all at once. End-to-end models, as we all know, are a great way of optimizing accuracy, but they're challenging because they require a lot of data, they require a lot of compute, they require long-term ownership of the thing, and they might even lead to an inconsistent experience if your end-to-end model is somehow qualitatively different than another end-to-end model in a different part of your product. So you got to be careful about just waving the end-to-end model magic wand over your stuff and thinking that just because accuracy is maximized that your life is going to be most happy. Okay, now you might be saying, this music thing is fun, I like thinking about vinyl records, I kind of like the movie High Fidelity, so I appreciate that you're referencing that. Or you may have never seen it for all I know. But this model of connecting customers to the domain, I think applies to, like I said, software products in general, ML software products. So I want to give you an example of that, just to think about it in another domain. Let's say you were just building NLP software, like Automatic Summarizer. What kinds of things are in your domain? Well, often it might be words, it might be the real-world entities that are of interest to the customers of your summarizer. And in this case, instead of having vinyl records down there at the bottom level, you might have word embeddings or a means of reasoning about words. And that might be independent or loosely coupled to the summarization application that one customer is interested in, because you've got another customer that's interested in entity extraction and linking. So I think this model of there are some things that are local and some things that are global applies across different machine learning product types. So, and let me emphasize that. So at the local side or the local end of the two places that your product is bridging, there's often less data available. So we had a lot of Spotify users in the room, which is great. If I think about how many tracks you've listened to in the last, say, month, it's a lot less than how many listens have happened on the platform overall. And if I'm trying to understand you, I have actually not that much data if I'm really into you. And of course, part of the purpose of machine learning is to allow us to generalize across more than one person. But at that one place, there's less data, but it changes relatively quickly. Like you might have gotten in, for all I know, you're going to go listen to Stevie Wonder's Talking Book after this, which I recommend. But maybe that's like you just decided that right now, and it's just going to change today. In contrast, global models have a lot more data. So if you want to look at every listen ever of Stevie Wonder, there's a lot of those on Spotify. And that data, it doesn't change as quickly proportionally. So the context, the other music that Stevie Wonder has played with, that's pretty well established. So I think it's useful to take advantage of this observation to help you do a better job managing your ML portfolio. So let me tell you what I mean by that. So if we consider the inventory, the alignment, the aggregation of models, or the single model with different pieces or weights in it that you're using to solve your product problem, you can have some balance between how much of it is more local, more global, as you're combining models to address your user problem. And you'll notice here, there's the ML product lifecycle down there across the horizontal axis. So what I want to tell you about is my thoughts on what combination, as you're leaning on local and global modeling approaches, what combination makes sense at different points in the ML product lifecycle. So starting out, I think you want to lean on more global approaches. So the reason for this, if you've got those around, maybe you've got a platform group or team, or even within your team, you've got existing models that are down at that global level. Reason for that is they're usually very available. They've already been computed. You can start experimenting with them quickly. You might be able to just put some heuristics on top of them to adapt them a bit to your use case. So global models are valuable in that they're low cost. You don't have to do a recomputation across all of the data that you have just for this product idea right here. Those global models do that computation. And similarly, there's this progression as you move through the product life cycle to where when you're at the point of wanting to build that specialized new thing because you've proven the value in that V2 and beyond, you have the license to go invest heavily in a local model because you've proven the value. You've proven to the business that there's value, and it makes sense to go hire a bunch of people or pull people off the other thing or whatever, fund a PhD student or something to go do this. There is an advantage, definitely, another one to global models, which is consistency. I was sort of alluding to it before, across the product, where the one value that global models give is not just their shared costs, but also they can pull together different pieces of the experience because if different product features are using similar global models, then depending on how they're using it, they may be, in a sense, consistent. All right, so that was our first challenge of ML product management, which was this misplaced modeling. And so my suggestion to address that is to progress from more global to more local models as you progress through the product life cycle. Let's talk about the second one, crude tools. So back to Rob, back to our sad means of providing Rob, Cool in the Gang, despite how cool in the Gang is. Let's talk about the delivery mechanism, the record player, the thing that's being used to provide that music experience. So you might have one like this, which was built in somebody's garage, I think. You might even have one like this, where you're having to literally hold it together by the skin of your teeth. I don't know if you feel that way about your production systems sometimes. But there's another workflow that I want to put in your head here to help explain and give some advice on this kind of management. And we're going to talk about the product life cycle under this too. But this is what I'll call the stages of the ML workflow. Hopefully these are pretty familiar to folks. You know, you have data pre-processing, you validate it, you transform it into features that you're going to learn from, you have modeling, and you train your model there, you evaluate it offline, and then if you have an online product, you serve that model to your customers, and then you would do online evaluation as well, whether it's A/B testing or other kinds of monitoring. So that's stages of a workflow. So I'm going to put these across the horizontal axis for this one now, and then I'm going to talk about where to get the tools that fit the different parts of your workflow. So you might get those tools within your team. You might say, we got to stop, we got to build this thing because it's going to be really great, and we're going to be able to like leverage, blah, blah, blah. Or it might be in your organization. Maybe you've got some team that provides kinds of infrastructure tools, or it might be some third-party open source package tool, or even a software vendor. So I want to give you a couple principles for choosing where to get your tools. The first is the points at either end of the spectrum are the places that make most sense to be higher on the vertical axis. The reason for that is that these are the points that connect with the rest of your organization. So your data pre-processing, that needs to connect to whatever your data store is, whatever your data engineering layers are. So if you go get some off-the-shelf thing from a vendor, but it doesn't work with your data store, you're in trouble. Similarly, at the other end, your online evaluation, that needs to be really tied to your product business value, right? And to how other people in your organization think about product value, and you need to be able to slice it in ways and look at metrics that really matter. In contrast, the thing that makes most sense to look outside your organization for is the core modeling, optimization routine, implementation of some bit of numerical optimization. Thank God for the people that build those things. I haven't built them for quite a while. They're really cool. I love the math, but the fact that someone else built it and has put it up for open source, that's great. I can use that as long as it meets my other requirements. And I think the other stages are basically following these principles interpolated between these points. Now you might, so just to make clear, I think you should share starting at the data end, because that's where, if you're going to do any kind of modeling at all, you got to slurp in the data. So if you can have tools within your organization that you can share, you can look at, invest in there. And then at the other end, so when you're thinking about what to invest in your organization, start at the ends of these to have shared tools. Okay, now how does the ML product lifecycle fit in here? Generally speaking, I think that as you move through the lifecycle, it pulls the middle of this up. So it's like it grabs onto the modeling place and pulls it up. The reason for that is, you'll remember we talked about the modeling getting more and more focused as you get further and further into the product lifecycle. So it might be that if you're in that V2 place, if you're going after, like this is so valuable, we're going to invest 6 people for a year in it to, go squeeze out that 3% from this corner of the market because it's going to be, X number of dollars. That's where you might say, okay, we got to build our own modeling toolkit. Nobody here has a, we're going to do it with a graphical model, and we don't have a good graphical model toolkit lying around, or whatever it is. We can also talk about, and maybe just one comment in passing, how the size of your organization affects this. Generally speaking, I think the bigger your organization, the lower down the green dots are, and the higher the green dots are. The smaller the organization, the lower down the green dots are. So like our hosts at Google, they're probably getting very little in terms of their ML tools from third party or open source. I mean, yes, TensorFlow is open source, but it's still a Google thing. Similarly, a startup, I would encourage you to look to get as much as possible externally and figure out how to demonstrate your value by addressing your product hypothesis and the way that the data flows through the tools, rather than being like, we're going to go build our own streaming data analysis system or something, unless that itself is your product. Okay, so that's the second suggestion for ML portfolios, is to strategically invest in shared tooling. Think about what things you want to share, what things you can get externally. So the third challenge is under-supported people. So back to Rob and his happy, pensive listening. In this case, what you want like happy makers of record players, and then they're there in their record-making factory, and they put the Union Jack on this one for some reason. So they're working away. But what ends up happening is also some kind of inner workplace team squabble or some other friction. And some of that is just because we're people and people are people, but a lot of it can be because the people don't have the kinds of skills that they need to exist through their product lifecycle, or they haven't been placed or allowed to place themselves in the kinds of team structures that are really valuable to deliver machine learning value. Okay, so one more of these graphs. So this one has skills up and down the vertical axis. So let me walk you through what these skills mean on the left side. So down at the bottom, understand ML. That means whatever role you have, not just the machine learning developers in the room. I'm actually sort of talking least about them at the moment. But let's say your product managers, your user researchers, your designers, the front-end engineers, back-end engineers, data scientists who are analyzing in the sense of analyzing data that the product gives off, not delivering models that enables the product to make decisions. So understanding ML means you follow along while other people are talking about the ML implications of this work, right? You're like, oh, yeah, okay, yeah. So, but you're not really giving input to it, but at least you don't feel completely lost. The next higher level of skill is being able to inform it. It's being able to say, well, what do you think about this, or how about that? Well, maybe this is an okay idea. I don't know. Next up would be driving ML. So you're saying, based on my experience, based on my expertise, I feel like this would be a good idea. And here's some evidence for it, and this is the direction we could go in, and other people could participate in that conversation, which would be great. That's that level. And then the top here is driving ML, where you're really in pursuit of the state of the art, where you're using, where the distinction between papers published in 2015 and 2018 is a big deal for you. So that's a really high skill level. So let me talk about the skills that I think are needed in different roles at different points of the product lifecycle. So we'll start out with some of these different roles. So I've got little icons here that represent different roles. So early, when you're looking at no new ML, most folks just need to be able to understand ML, and then say the ML engineer and the product manager, they need to be able to inform it in the sense of thinking, well, maybe this is a place maybe that it would fit later on, I don't know. Right now, we're really just trying to get a little more intuition about the product hypothesis that we're in pursuit of. Then as you move to prototyping the ML product, you need the ML engineer to be able to give specific suggestions and ideas and start to drive. And the product manager also needs to be able to participate, follow along, and be sort of a foil or a conversation partner to the ML engineers. And you get into the minimum viable ML product. So notice the folks, the data scientists, the designers or user researchers are also coming along. And again, the data scientist distinction for me, data scientists in my nomenclature inform decisions made by people. Machine learning engineers inform decisions or build things that enable products to make decisions. So through the progression here, you're moving up and up all the way until V2. So V2, remember, this is where papers published in 2018 matter. So you need an ML engineer to really be able to drive the state of the art. You also need a product manager, because the product manager needs to be able to help assess the value of experiments that are going to be pulled into however you're organizing it, a sprint or something, and they really need to be able to interact with that. Other engineers who might be building back-end systems, maybe they just still need to be able to inform it. For V2 designers or user researchers, they need to be able to think of, oh, wow, this has a different, wow, interpretability here is different, so we need to have the surface of the thing, express explanations, or, the error profile is different, so we need to give users different ways of addressing that. Okay, within the ML engineer role, there's actually a few different flavors. I'll run through this quickly. I think of machine learning product delivery as like carpentry. So your applied machine learning engineer is like the carpenter who knows how to take the raw material, data, and turn it into something useful. There are tools engineers who are like blacksmiths. So they're building the things that enable the carpenters to turn data into products. And core researchers are at the coal face of nature, finding out new things, new particles, new materials that the tools engineer can deliver. So applied ML engineers, it's important for them to have more product-oriented skills. Tools engineers think about infrastructure, connections with other bits. And I think, generally speaking, the number that you need decreases as you go down this hierarchy. And it's sort of like an analog to the tool shape or other shape, where getting to those core bits, you don't need that done quite as much. A lot of it is about connecting to the domain, connecting to the rest of the infrastructure. So just to flesh out where I think these roles fit in the product lifecycle, they're not exclusively in these points, but I think the tools engineer and the core researcher comes in later in the product lifecycle. All right, let's talk about team structure. So we talked about skills that help people be more supported in managing your ML portfolio. Now we're going to talk about team structure, and this is our last little bit. So here, the trade-off, this is my last one of these graphs, the y-axis is yet again something different. I think in software engineering, there is this trade-off between isolation and integration, right? So like our designs are all about this. Well, if we integrate them, then it'll be easier to pass stuff around, but if we isolate them, it'll be easier to advance them together, right? Similarly, for ML work in a team, there's this trade-off between isolation and integration. Isolation allows focus, integration allows alignment. So early in the product life cycle, and really in the organization life cycle, if you're an organization that hasn't done that much ML, I think a centralized ML squad makes sense. It allows for collaboration, but it's harder to be product aligned. And you think about what things you might be delivering. So those could be models like, we're going to fill up this bit bucket with a bunch of floating point numbers, or systems like, here's our microservice over here, or development effort where you're like, oh, this person is going to be 100% on this other team for this quarter or whatever. So that's how you start. And in my little diagram here, you remember the ML engineers are the purple people, or maybe that's blue. So they're centralized in this one team, and they have relationships to these other teams. You move into later into the product life cycle. This is the place where you're really in pursuit of value. You're moving from hypothesized value, experimented value. You're iterating on the product shape and the product hypothesis a bit. This is where embedding is most valuable because you don't need to go pursue some really complicated ML model. You just need to know what's possible. So there's less collaboration among ML engineers. So the folks on the teams need to be more senior to really represent the discipline. You need to have more connection across the team. So we have chapters at Spotify that does that. And the product manager needs to be able to cross-prioritize across the different kinds of work. Then as you prove the value, you might say, okay, now we need to start investing in really the core modeling again, where you might have a separate machine learning work stream within a single team. And there's a lot of spectrum for this, like how much are shared rituals, shared documents, how much are separate. So, and this is where you might do higher level prioritization, where you say, okay, well, these folks are going to be in this work stream for this amount of time and these in that work stream, and not worry about individual pieces of work. Then finally, a sibling squad. So remember, here at V2, this is where you're going after that step change. So this might be where you say, we're going to carve off part of this team. They're going to go in pursuit of this objective, and we'll check in with some structure, but we're not a single team. They're a separate team now, and they're going to be delivering stuff to us so that we can experiment with it. I want to emphasize, this should really, I think, usually be a rare state, because you have to ask yourself, is it worth doing this, or is it worth going in pursuit of some other product hypothesis? Like, is that extra little % that you're going to squeeze out of there really worth separating in this way? Okay, so we've talked about these 3 challenges for ML portfolios and had these 3 suggestions to address them. So just to review, we're going to progress from more global to more local models. We're going to share, we're going to build our own tools where it connects to the organization, or at least err on that side. And the core modeling, we're going to look more outside ourselves. We're going to allow people to, or we're going to encourage people to progress in skill and look for a level of skill that's consistent for where we are in the product life cycle. And we're going to organize our teams so that integration is most important when the product hypothesis is most being validated. Okay, so all of this is going to lead not just to a happy Rob and all the other people, but also to a happy Lloyd. Any Say Anything fans, all right, or John Cusack fans, it's okay. It's okay, we're all nerds. So with that, I will say thank you very much. I know we have maybe a couple minutes for questions. And here's some suggested questions if you want to, if you don't have questions of your own. So I guess you can come up to the mics if you want to ask there. Oh, sure, yeah.
So you spoke about all the roles of what I would imagine as sort of a, I'll stand up, what seems like more of an established machine learning product integration for a business. I'm curious about, like, for myself, strictly speaking, we're just getting started. Mm-hmm. I'm not even sure that there are any academic papers much to even to go on. I have a hunch that this will be very valuable for us in the business going forward. So how does one get started in that space? What kind of investment do I need at that stage?
Right. So have you achieved, or do you think you've achieved product market fit? If you haven't, then I'm not sure you need to go after ML all that much. I think you want to be thinking about, you're in like the upper left-hand corner and you're thinking about, have we found anything valuable at all that we could sort of invest in? If you have achieved that and you've got something that seems to somewhat work, but you're like, it feels like ML could make this better, then I suggest the following process. So ask yourself, what are your high-level business metrics? What things are you trying to move? And then ask yourself, what fuzzy decisions does the product make that impacts those? So fuzzy decision might be like, how are we ordering these things that we're presenting to the user? Which one of these things do we show first? Or who do, these things where it's not as if you can write down and know exactly what the right answer is. Those are the places where machine learning can fit best into the product. And so when you've identified those, that's where you can get in, say, a relatively senior machine learning engineer who's interested in your product domain, because we want to love our customers even more than our code, so they got to be bought into the product domain. And those folks can say, okay, well, given this fuzzy bit and this fuzzy bit, we can, this feels like this kind of model, and this feels like we could grab some relatively off-the-shelf thing. And then only when you really have proven the value do you need to go in pursuit of the, PhD expertise person. I think it's a failure mode sometimes, unless you're like trying to unless you're in the upper right hand corner and you're like, we're getting down to the bottom left, which is risky, right? So, but if you can do that, more power to you. But unless you're doing that, I don't think you need, heavy duty scientists. I don't know, we could talk about that. I did a whole other talk in January on product and ML that is online. You can look at for more on all that stuff.
I think we can do one more question if anyone's got one.
I'll go back to the suggestions. If you want to pick one.
So I hear you're up for Mass TLC.
Yeah. Thanks, Mike. Yeah, we are. So I think it's October 3rd is the banquet. So one of our products at Spotify are the This Is playlist. So if you search for an artist, often you'll see This Is, whomever. And the vast majority of those are built in what we call an algatorial way. So that means we have a model that has some human constrained correction on it, but it's a means of delivering an introduction to an artist to users without having to go have a ton of editors spend their time crafting exactly the right thing. So we're excited about it. It's been developed in the last year, so we'll see what happens then with our other very worthy co-finalists.
Cool. Then I think we'll thank you very much. You can probably attack him during the break at some time if you have more questions.
Yep.
And now we'll bring up Dan. But I